Okay, we're going to continue talking about exponent rules here, and this time we're going to talk about what's called the product rule. And so I can here use properties of exponents, and that property that we're going to focus on in this video is the product rule. And so just a quick review here of what an exponent means. Just a reminder that m to the fifth here means that I am multiplying m times itself 5 times. So it'll look like this over here. M times m times m times m times m. And so we're going to use that concept here to talk about what happens when I multiply something times another something that has the same exact base. So if I use my definition here, I know that m to the third really represents m times m times m. And I really know also here that m to the fourth represents m times m times m times m. And now the last piece here is that they were being multiplied together, so I still have that multiplication in between. And now if I look at this in terms of what the definition of an exponent is going to tell me, I know that I have 1, 2, 3, 4, 5, 6, 7 different m's here, so I have m to the seventh, and that's what my definition means. And so as we go through these examples, I want you to keep in mind what we end up with as an answer for our exponent, and maybe what our exponents at the start of our problem were, and maybe how there's a relationship between these. So if I look at something here with maybe 3 terms, again, if I use my definition, I know x squared is going to be x times x, times, because I have multiplication in between, x to the third, and let me put parentheses around this so I know that x squared was that. I've got parentheses here, and I've got x to the third. X to the third means x times x times x, multiplied by, and I've got x to the fourth. So I'm just using the definition over and over and over again here to expand this thing out so that I can go ahead and look at what's going to happen. So now when I look at x times x times x times x, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. 9 in my pattern of repeated multiplication tells me x to the 9th power. So again, keep in mind that we have a 9 here, and we had a 2 and a 3 and a 4. So this is kind of the ultimate here of one of our more difficult product problem things, because now I have numbers, I have some x's, and I have some y's. And so here's what's going to happen. We're just going to take these and we're going to separate them out. Each piece as it would look. So 3x to the third y is going to look like this. Every piece up here in my original is being multiplied together, and so that's what we have inside of my parentheses. Times, in my other parentheses, I've got a 2, and I've got an x times x, and then I've got y times y. Now here's what we do for these kind of problems. I'm going to look at my number here and my number, and notice that if nothing else was included here, I would just have 3 times 2 in terms of my numbers. So 3 times 2, I can go ahead and multiply. That's 6. And then what I'm going to do is I'm going to look at just my x terms. So just my x terms, because they're the ones that are alike. And I have 1, 2, 3, 4, 5 of those things. Remember, everything here is being multiplied. So I've got 5 of those pieces, so x to the fifth. And then when I look at the y's, I've got y, and a y, and a y. And again, these are all being multiplied together, so I've got 1, 2, 3 y's being multiplied together for y to the third. So after I have simplified this thing, I've got 6, x to the fifth, y to the third. And so here's what we're getting to here is our product rule. And if we've noticed any patterns throughout the problems that we've looked at, we might already kind of have seen this. But I have a to the m times a to the n, and first of all, these have to have the same base, so they both have to have a. And if that is the case, and they're being multiplied, then I can add the exponents. So if we go back here just for a second, and we look at our very first original example here, we had m to the third times m to the fourth, and when we wrote that all out and we counted them, we noticed, oh, we have 7 of them. But a trick or a shortcut is that, hey, I had the same base, and so I can add these exponents, and 3 plus 4 certainly is 7. So we can see that it does, in fact, work. So we're going to use the product rule here to simplify, and I've got x squared y times x y squared. So I'll show you both ways. I'll show you first of all with the definition, the way that we have been doing this. And if you would prefer to use this way, by all means do so. The product rule is just a way for us to do things just a little bit faster because we've noticed a pattern. So x squared y would look like this. That's my first parenthesis, times x times y squared. And so when I look here at just my pieces, which are x, I notice that I have x times x times x, and that's x to the third. And then when I look at my pieces, which are y, I've got y, y, y. I also have y to the third. So I've got my different pieces there. And if I look at this thing in terms of the product rule, instead of the definition, let's see if we do in fact get the same thing. So I'm just going to rewrite the problem, x squared y times xy squared. And one thing that I don't know if we've talked about yet, but if there is not an exponent listed, like here, there's no exponent listed for y, it's just a 1. And so when I look here at my product rule says take my like pieces, so in this case, my x's, and I can add those exponents, 2 plus 1. And I can do then the same thing with my y's. My y exponent here would be a 1 plus a 2, so a 1 plus a 2. And when I simplify that, I get x to the third, y to the third. And sure enough, that's the exact same thing that we got up here when we used our definition. And so that's why the rule works. So let's take a look at one more example here. And go ahead and do this one on your own. So hit pause, work it out, and then when you're done and you want to see the answer, go ahead and hit play. So I'm going to use the product rule here to simplify this. And so I would have a to the 4 plus 3 as my exponent, because I am looking solely here at my a terms. And I've got a 4 for an exponent and a 3. And when I look at my b terms here, I'm going to have 2 plus 8. And my last thing that I need to do here is simplify, so I would have a to the 7th, b to the 10th, and I have that thing simplified. So we're going to practice some problems here with the product rule, and let me know what questions that you have as we're working through this.